Okay, in this video we're going to be looking at solving two-step equations. So we've previously looked at solving one-step equations, now we're going to look at solving two-step equations. So, a few steps that we need to take in order to solve two-step equations. The first one, and the first thing we always do, is we undo the addition or subtraction. So we're going to use inverse operations to undo our addition or subtraction first. Always the addition or subtraction first. Every two-step equation is going to have either addition or subtraction. You have to undo those first. Second step is to undo multiplication or division. So after we've undone the addition or subtraction, then we undo the multiplication or division. And again, we use inverse operations to do that. So again, first thing is undo addition or subtraction. Second one is undo multiplication or division, whatever the problem tells us. So let's look at an example here. My first example is 6r plus 19 equals 43. 6r plus 19 equals 43. Now, in order to solve this, the first thing I need to do is undo addition or subtraction first. So I can see that in this problem, it's plus 19. So I need to undo my plus 19 first. So to undo addition, I'm going to do subtraction, and I'm going to subtract by 19. Again, my whole goal, as I'm going through this, is to get that r by itself. So when I subtract by 19, those end up canceling. I'm left with 6r equals, and then 43 minus 19, I have to borrow, comes at 3, comes at 13, 13 minus 9 is 4, 3 minus 1 is 2. And now from here I have 6r equals 24, or 6 times r equals 24, which is multiplication. I need to go ahead and do the inverse, which is divide. So I'm going to divide by 6 on both sides. 6 divided by 6 cancels out. I'm just left with r equals, and then 24 divided by 6 is 4. Now, in order to check this, we go through the same exact process. Okay, I'm going to do my check right here. I write my original equation, 6r plus 19 equals 43. And then I plug in what I think r is. I think r is 4. So it's going to be 6 times 4 plus 19, and I'm hoping all of that equals 43. Now I just follow order of operations. 6 times 4 is 24. Bring down my plus 19, and my equals 43. And then 24 plus 19, 9 plus 4 is 13, carry the 1, 2 plus 1 is 3, plus 1 is 4. So 43. Does 43 equal 43? Yep. So I know that that is my correct answer. Let's do another example. X over 5 minus 4 equals 10. X over 5 minus 4 equals 10. Same steps. I need to undo addition or subtraction first. Since I have subtraction, I'm going to undo that by addition on both sides, and I'm going to add by 4. My minus 4 and my plus 4 are going to end up canceling here. So on the left-hand side of the equal sign, I'm left with my x over 5. I bring down my equal sign, and then 10 plus 4 is 14. At this point in time, I just have a one-step equation left. X divided by 5 equals 14. So I do my opposite of division, which is multiplication. And I'm going to multiply both sides by 5 now. Those cancel. I'm left with x equals, and then 14 times 5. Well, 4 times 5 is 20, so carry the 2. 5 times 1 is 5, plus 2 is 7. 70. So I think x is equal to 70. I should go back through and check this by plugging it in back into the original equation. X over 5 minus 4 equals 10. So I'm going to plug x in as 70. So 70 divided by 5 minus 4 equals 10. So I have to do my division first here. 70 divided by 5. Let's see, 5 goes into 7 once with 2 left over. 5 goes into 24 times. So 14 minus 4 equals 10. 14 minus 4 is 10. So does 10 equal 10? Yep. So I know that's my correct answer. Let's look at another example. Example C. It says 3x minus 9 equals 24. 3x minus 9 equals 24. Undo my addition or subtraction first, so undo my subtraction. Adding on both sides, and I'm going to add by 9. Again, my whole goal is to get that variable by itself. So on the left-hand side, my minus 9 and plus 9 cancel. I'm left with 3x equals, and then 24 plus 9 is 33. So I'm left with a one-step equation, 3x equals 33. I can now divide by 3 on both sides to undo my multiplication. And I'm left with x equals 33 divided by 3, which is 11. Now I want to go back through and check. I plug x into my original equation, 3x minus 9 equals 24. I think x is 11, so I'm going to do 3 times 11 minus 9 equals 24. 3 times 11 has to go first, which is 33. And then 33 minus 9 is 24. So does 24 equal 24? Yes. So I know that that is the correct answer. Let's do one more example. Example D. Oh, now we got some negatives. Negative 8y minus 28 equals negative 36. I'm going to undo my addition or subtraction first. It's minus 28, so I want to add 28 on both sides. My minus 28 and plus 28 cancel out. I'm left with negative 8y equals, and now negative 36 plus a positive 28. They have different signs, so I would need to do absolute value and subtract. If I do my absolute value and subtract correctly, I should end up with negative 8. Now, from here, I have negative 8 times y equals negative 8. So my operation is multiplication. I need to divide on both sides, and I'm going to divide by negative 8. On my left-hand side, negative 8 divided by negative 8 cancel out. I'm left with just y equals, and on the right-hand side, negative 8 divided by negative 8 is a positive 1. So I think y is equal to 1 here. I should go back through and check. So negative 8y minus 28 equals negative 36. I think y is 1, so that's what I'm going to plug it in as. Negative 8 times 1 minus 28 equals negative 36. Negative 8 times 1 is negative 8. Okay, so I have negative 8 minus 28. I'm going to do that adding by the opposite. So now I have negative 8 plus a negative 28. I can add those two since they have the same sign, and I end up with negative 36 equals negative 36. So I'm good there, meaning I'm good here.